Radar, one of the most important technological breakthroughs in history. During the First World War, the only way to spot aircraft was with men on the ground with binoculars. This worked during the war, but during the interwar period, aircraft became a lot faster and larger. As a result of this, the need for a technological breakthrough in aircraft detection was critical. In 1935, a man by the name of Sir Robert Watson Watt invented the first practical radar. Early radar was very crude but reliable. Radar could tell you where formation of planes was, but not the plane's altitude or how many planes were in the formation. The British decided that if they were going to use this new technology, it would have to be in a ground-based system. In the early stages of World War II, Britain had managed to acquire a German Enigma machine. After decoding their messages, they listened in to German plans and orders that were being sent from one HQ to another. They could see the Luftwaffe formations farming up over the French coast. They could see the size and direction of the enemy flight path and told them of orders from the German High Command, or any movements either by the German Navy, Luftwaffe, or Wehrmacht. Britain had a very clear picture of just about everything that was taking place within the German military machine. The German High Command had failed to plan for their Enigma codes being broken, and as a result, their entire planning was faulty. In 1927, while working for the Technological University of Darmstadt, Professor D. Hans E. Hallmann developed and built the first ultra-wave shortwave transmitter and receiver for centimeter and decimeter waves. This work led to the development of the world's first microwave telecommunication system. In 1928, he graduated with a thesis on Bockhausen electron oscillations. At this time, a scientist by the name of Hans Carl von Wilson became good friends with Hallmann because he too was interested in ultra-short waves. The two, with another man by the name of Gunther Abstro, started a company called Gamma. Hallmann and von Wilson were the technical experts, and Abstro was the manager. Gamma built the first radio transmitter in the autumn of 1934 for detecting ships. The radar operated on 50 centimeter wavelengths and could find ships up to 10 kilometers away. In the summer of 1935, a pulse radar was developed with which they could use to spot the ship Koenigsberg, 8 kilometers away. This radar unit used the Rauschen tubes and had accuracy of 50 meters. A magnetron had been tried, but the frequency was not stable, and as such, tubes were used. A wavelength of 60 to 80 centimeters was used so the sender and receiver could be spaced closely together. An airplane at a height of 500 meters and a distance of 28 kilometers could be seen. By 1935, they had built the first successful radar unit for shipborne application. They used the same radar system except that the shipborne system operated on a wavelength of 80 centimeters instead of 1.8 to 2.0 meters. The land-based radar was called Freya, and the seaborne radar was called Seetocht. Based on Hallmann's work, a microwave department was set up at Telefunken in 1933. This company set about designing the Darmstadt radar, named after the university which Hallmann studied for 9 years. In 1936, this radar was named after the Weserberg. A parabolic antenna with a diameter of 3 meters and a rotating dipole was used. The first unit had a range of 10 kilometers with a distance accuracy of 100 meters and an azimuth and elevation accuracy of 0.25 degrees. The new radar was demonstrated to Commander Udet of the Air Force, and he commanded, "If you deploy this radar, it's going to take all the fun out of flying." By 1937, the range had been increased to 35 kilometers. The Weserberg operated on a wavelength of 53 centimeters. During the war, the Freya and the Weserberg were paired so that the Freya would spot and track incoming aircraft, and the Weserberg would determine the exact range and height when the aircraft came closer. The Weserberg Reis was used to detect fighter aircraft against the incoming bombers. Radar, a technology that was developed for war, but has evolved into something that is taken for granted in peacetime. Radar was developed as a means to track incoming enemy aircraft and find ground targets to bomb. It is now used to monitor commercial air traffic, track weather patterns, and aid in general navigation. Radar saved tens of thousands of lives during World War II, and is now used to provide basic comforts to society, like telling when it's going to rain or snow next. Radar is still in use by every major military nation today. For the United States, it is often used in our guidance-based weapons and missiles.